Hey guys, thanks for coming. Howdy. My name's Yalif. I'm the CEO of Intelliminds, and for the last few years, we've been helping growth teams better connect with their customers by using AI to improve their online engagement, which has driven a bunch of revenue and a bunch of what they wanted out of their products. For me, that journey began a long time ago when I coded a rules-based expert system. Can you hear? Audio? No,
Turned off.
Let's see.
There's a little green on the top.
Orange on the top. There we go. My bad. Okay. So for me, that journey began a long time ago when I coded a rules-based expert system to design airplanes in college. And since then, I spent 10 years as a product manager, 10 years as a marketing guy, serving growth teams across industries at Twitter, Brightroll, and Yahoo. Today, I want to help make you better consumers of AI by helping you poke holes in what you're hearing, get more out of your investments, and take better approaches when you're making AI investments. We believe that AI can help each one of us advance our careers, deliver more for our companies, and get more done. And so we'll spend the next 30 minutes talking about practically what are the different kinds of AI that we should know about as product people, and a couple of examples of how people have put this to use in day-to-day life. So please jump in, ask questions anytime. So anybody have a sense of how would you define AI? Anyone?
It learns.
It learns. Yeah, that is a great definition, in particular for machine learning. And most would often say AI is a computer doing something we would consider intelligent. And it's all around us. I mean, these companies today helped us figure out how to get here faster, entertained us, helped us avoid reading spam email. It is pervasive in our personal lives. And it turns out it's particularly good at a few things that are really helpful to us in our professional lives. Anybody have a guess what these four numbers are? The first, they each illustrate something AI is really good at. AI is really good at managing a lot at once. 4.5 billion is the number of versions of a page. A growth professional got up in front of a conference a year ago and said, hey, I'm managing that number at the same time using AI. AI is also really good at accelerating learning. Our average customer last year personalized flows that would have taken them 25 years had they used traditional A/B testing. It's also good at, unlike us humans who get tired and fallible and distracted, it's good at listening and reacting 24/7. So 4 hours is the amount of time it took one of our customers to see different experiences showing on their website after they ran a promo and the traffic changed. And 1 is the size of the segment to which AI can help us personalize. It can act with superhuman levels of precision, enabling us to deliver one-to-one experiences that we've been talking about for a long time. And I want to talk about how that happens. Now, AI is really good at these things. It's not so good at some other things. I'm going to pull examples more from personalizing site experiences for growth professionals, because that happens to be what my company is doing. But these apply much more broadly across what we're doing as PMs and as growth professionals. But if you're thinking about optimizing a site, you need to do 3 things. 1, you need to have customer intimacy. You need to empathize with your customers and understand a day in their life. 2, got to be creative. Got to come up with a bunch of ideas of things you want to put in front of your prospects to get them to become a customer. And 3, you need to manage a lot at once. You need to manage a bunch of experiments. AI is not particularly good at human empathy and human creativity, at least not yet. And so we think the best outcomes happen when you pair human intuition, creativity, and empathy with machines that can do a great job managing a whole lot at once and accelerating what we're doing. And you can do that today. I'll pull examples from marketing, but they are things I think we can all learn from throughout the marketing funnel. So our brethren in paid media have been using AI out in the open for 10 years, right? When Google says, hey, give me 5 search ads, not 1, it's using AI to figure out what's the right one to show each individual visitor, and it feeds the winners and starves the losers automatically. Persado at the top of the funnel is another example of a company trying to create more engaging email subject lines. It's trying to be creative automatically. You go mid-funnel, there are companies like Madkudu and Infer that are creating batch models to try to predict, hey, I've never seen this company before. Are they likely to be a high-value prospect? Are they actually low-value prospect and I should keep them away from sales and point them to self-serve? Even further down the funnel, you've got companies like Drift and Intercom, which are enabling growth professionals to create playbooks, rules, that they will then go execute to go interact with prospects, enabling live selling. Now, we'll draw, as I mentioned, examples from websites. The principles will apply more broadly, and I'd like to talk about the different kinds of AI that are out there. We'll talk about distinctions that I think matter to us as PMs, practically day to day. We're not going to go super deep or into any of the math, but rather on the intuition of what matters. So, at least on websites, folks begin without AI at all. Right? They run an A/B test. We're all familiar with them, right? You give half your traffic to one thing, half your traffic to another. You wait till you reach statistically significant differences, which happens about 20% of the time, and you pick a winner and you go code it on the site. It's great because you're using data to decide what you're showing, but then we often ask ourselves, like, is everyone really the same? And so we want to do something a level further. And often, we'll turn to rules. We'll create if this, then that statements like this one, where, if somebody's in San Francisco, I'll show them the Northern California promotion. It's great because you're not treating everyone the same way, as we often don't want to do in our products, right? We want to have personalized experiences in them. And often, when you're hearing folks talk about AI, they're really doing this. They're doing these if this, then that statements. You see it all the time in like marketing automation, in Marketo. You see it in the bots I was talking about before, the chat. It's pervasive, and it gets people wanting more. They say, look, I got more of the engagement and revenue I want because I created these rules, so they create more of them. They say, look, if somebody's in this particular situation or context or has exhibited these behaviors, I'm going to show them this message or open up this feature to them or give them this experience. And often we'll say, great, that worked. I want even more. And so you end up with a huge number of rules. My co-founders were personalizing the Yahoo homepage. If they wanted to create a rule for every city in the US, they'd have the daunting task of creating 35,000 of them. It's not tenable at that scale, but it is particularly useful in certain situations. I'd suggest you think about rules, one, when you've got a hard business rule. Perhaps for a marketer, you've got a promo in a certain area of the country, or as a PM, you've got a feature that you can only enable for a certain group of folks. And two, if you've got machine learning scientists on your team, this is a great way to go check out if there is lift in something. This is a good way to, in a half a day, go try something out rather than them spending 3 months building something that you're not sure it's going to work. And it's often implemented as an A/B test with an audience or with rules-based personalization or with an expert system, which is really just a bunch of if-then statements organized effectively. This happens to be the one I wrote in college. Any questions so far? Oh. So I think intuitively I wouldn't. Machine learning folks do. They do say this is rules-based is a branch of AI formally. I think what we're all used to calling AI is machine learning, is where a machine is learning on its own. Question?
Also, would you use the word heuristics to describe a rule-based system mostly?
I realized I'm going to repeat the question just so it can go on the audio. So the question was, would you call it heuristics when you're using rules-based AI? Absolutely. In fact, the expert system I showed you before was specifically built to do that, where it was saying, look, when you're designing an airplane, there are a bunch of rules. There are also a bunch of things you learn from experience. Experienced airplane designers know these rules of thumb. You can encapsulate those in rules. So yes, I think it's a great idea. Question?
What's the difference between fuzzy logic and AI?
What's the difference between fuzzy logic and AI?
It's kind of blurry between these two, right? So you've got logic that improves itself, understands something. So AI seems like everyone's calling it AI now.
Yep.
And so I'm just seeing what really delineates some logic that can learn versus something that's really learning on its own and doing pretty impactful things.
I think you're spot on in asking a question saying, look, people are slathering AI on everything in their marketing. They're saying everything is AI, like the question about rules-based. They would say, hey, that is AI. If you can hold the question for one more slide, I'm going to talk about what I believe are the distinctions in the machine learning tree, the hierarchy, that are relevant for us. Transparently, fuzzy logic isn't one of the ones I had on my radar, and maybe we can map it to that as we go through it. Okay? Machine learning is where a machine is teaching itself. You've got a bunch of data, and you need to be thoughtful about that data. Some algorithms require Google scale data in order to work. Some other algorithms require data that's really expensive for you to go get. Be thoughtful about that as you pick the approach you're going to take. 2, you then have a model that's being trained. And you want to pick the right model, the right approach for the problem you're trying to solve, and we'll talk about that next. But the model Mad Kudu is using to predict lead scores is very different than the model you would use to go do A/B testing on a website. And 3rd, you want to then create a prediction and put that into production. You want to use that to change what your users or prospects are experiencing. And you want a system that will help you do that quickly, where those learnings are being put out into production regularly. Now, let's talk to your question about the different kinds of problems we might solve and some of the kinds of algorithms that would help us go do that. To build some intuition, I'm going to draw from the world of marketing. You can draw direct parallels to the world of user experiences and product. So on the left, I'm going to talk about different kinds of problems, and on the right, some classic kinds of machine learning algorithms that are often used to solve them. Please interrupt with questions throughout. So if you're trying to predict something that is continuous, like a lead score, like how much should I charge for something, where there's an infinite number of values, right? You're trying to predict something between 1 and 10, where any number in between is an option. Linear regressions are the most typical way to approach that. And a lot of the machine learning we see out there is doing that. It's trying to fit a model to predict a number, like housing price, right? I might have a model that has the square footage of the house and the price at which it's sold, and I'm going to train a model to predict price based on square footage. It's a continuous number. If instead you've got discrete values, like I want to predict if somebody's high lead score or low lead score, or I want to predict is this email spam or not spam, then classification algorithms, logistic regression being the most common, are the approach that is most often used. It's trying to classify between 2 or multiple different classes. Make sense? 3rd, there's a whole group of recommendation algorithms, particularly relevant to us as PMs, where you might want to know, hey, what's the right product for me to show? What's the right content for me to show? Some of these are based on, hey, the 2 of you behave the same. You might like the same things. There's a whole nother approach to it where you might say, these 2 products are similar, so if you like this product, you might like that product. So you generally can come from the user behavior end or from what I know about the product end, depending on the data you have and the problem you're trying to solve, how you want to solve it when you've never seen someone or never seen something, a product before. So those are recommendation algorithms. Next, there's a whole group that gets a whole lot of press nowadays. When you've got Google scale data, you can do things like trying to understand speech, try to recognize images, try to write an email subject line. And often deep learning shows up here. And deep learning is a fancy word for neural networks that have a bunch of layers in them. And they take an awful lot of data to train. And then they can do magical things when you can train them that way. Or you can train one to go solve chess. So speech and image recognition is a whole class of problems where you will often see deep learning neural networks. Then sometimes we want to know more about our customer base. We've got a bunch of data about our customers, and the goal isn't, hey, can I predict a certain thing, like that housing price, right? I want to predict a certain output. Here, it's not that at all. Here, you're trying to find patterns. You're like, find me the clusters in my data. Find me the clusters in my customer segments. Clustering algorithms are particularly well-suited to that kind of problem. A couple more to share. There are times where you want to detect when something's unusual, an outlier. This kind of machine learning was initially pioneered. Some of the early work was done with aircraft engines. People wanted to predict, hey, when is the engine on that jet going to fail? I want to pile in a whole bunch of data about the engine and predict. I don't know which piece of data matters, but I want to predict that. It's often used in products to predict fraud. You know, is this sign up real or is it not real? And the core question this algorithm's asking is, here's everything I know about people who've been successful. Is this new example like that, or is this one an anomaly? Is it different? That's kind of the intuition around this one. And lastly, there's a different approach called reinforcement learning that is suited to problems where there are three different things. Feel free, you may take a picture again in a minute because I'm going to add two more things to this slide. Reinforcement learning is particularly suited to problems like chess or Go or checkers where you, one, only get to learn about the moves that you make. Like if I'm playing chess and I want to learn, hey, if I make this move with my piece, I'll get to learn the outcome of that. I don't get to learn anything about all the other moves I might have just made. That means part two of reinforcement learning, you have a trade-off between exploring, should I make one of those other moves, or exploiting, should I go do the thing based on what I know now, is the best thing for me to go do to win this chess game. That's an inherent trade-off in reinforcement learning. And the third characteristic of problems that are solved well with reinforcement learning is that you only get an answer at the end, right? You make 100 moves in a chess game, however many it is, you only know if you've won at the end. And so you need an algorithm that can take that end result and feed it back through all the interim steps you made before to see, hey, were they good ones to make? So those are reinforcement learning problems. Now, these are a bunch of classes of machine learning problems. There's a meta level above that. And now you can take a picture if you want. I mean, feel free anytime, but this is the complete slide. The ones at the top are called supervised learning because there is a particular outcome you want to predict, and your training data has that outcome in it. Like if you're going to predict housing prices, you're going to be fed a bunch of data. Here's, the square footage, and here's the housing price. So you know the outcome, and you're trying to match data to that. Unsupervised learning does not have in the training data the particular thing you're trying to predict, right? We talked about a very unstructured problem here. What are the clusters in the data? I don't know what they should look like. It's that kind of problem, and reinforcement learning is characterized by the three things I described before. It has elements of both in it. I'm going to pause there for a second. Questions?
You mentioned chess in the context of speech and image recognition and verification in the other section.
It was a mistake to mention it here. I mentioned it because sometimes this is implemented with neural networks, and I was talking about neural networks up here. It really does fall down here, not up there. Thank you for asking.
So where does the role of having a discrete outcome that can be measurably play? I understand there's a difference between supervised learning and unsupervised learning there, but just as sort of a layperson, I would assume that you need to have some kind of outcome to be able to train any kind of system.
The question is, don't you need a discrete outcome to train any kind of system? The answer is yes. But the way you frame the outcome will be totally different between a supervised and an unsupervised learning problem. So all these approaches, when they're going through that loop we described before, they're saying, here's some measure of goodness, and I want to minimize how wrong I am. So in supervised learning, the measure of goodness is I needed to predict a certain value, a certain thing. Did I predict it well? In unsupervised learning, I'll pick on clustering for a minute. You will say, I want to create clusters so that the error, the badness, is as small as possible. So you can imagine a whole bunch of points, like imagine I had a whole bunch of dots here in a two-dimensional grid. If I picked clusters that were here, the center of the cluster would be really far away from each of these points. If these were the two sets of dots and I picked clusters that were right in the middle, now the distance between the center of the cluster and the dots is less. That's the intuition. So you're minimizing this error. And here you would say the error is how far off is each piece of data I have from what I'm predicting is the center of the cluster. So there is something to minimize. It's just not part of the training data. Because the training data didn't come with which cluster should this be in. Whereas here, it did come with that, right? You did know the housing price. Does that make sense?
It does make sense, yeah.
Cool. Other question?
One of the challenges with all the models that we have seen is how do we bring in confidence in stakeholders and how do they make these decisions based on whether this really works or not. So validating these models, and even though it is accurate, unless people have confidence in using the outcome of models, outcome, end of the result is, end of the day, people are not using for making decisions, it's not necessarily good. So have you come across some of your challenges, and how do you?
Question is, how in an organization do you get people to believe this really works and have them making decisions based on this? I'm repeating it just for the camera, not because we have run into it, and often we have gone with data. So often the machine learning scientist will break up the training data they have into two parts. You may ask them to break it up into three if I get tactical for a minute. You'll have the part on which you're training the model. You're using that over and over again. You'll have the part on which you'll check how far off was I in the thing I'm trying to predict. So you avoid a certain class of problems called overfitting and underfitting. Then you'll have a third bucket of data, and that's the one you'll show to your stakeholders. Because you'll be like, I trained the model over here. Now here's this stuff I've never seen before. Look at how good it is at predicting this. You'll use the data itself to say, hey, look, this really does work, and invite them to bring their skepticism. Invite them to say, okay, well, then let's try it out over the next period of time and see with this data we never even had before how well it does. In particular, if you can do it in parallel with what you're already doing, you can say, hey, look, the stuff we're doing produced this value. This thing produced this much value at the same period of time, sort of a head-to-head, is one of the techniques I have found useful. Another, it often is less useful to try to walk somebody through the math, depending on who they are. So this is a nice, clean tree, nice, clean table. Reasonable, experienced machine learning people will disagree on this. Most would say this looks reasonable. Some will quibble with one part here or there. But there is no sort of universal truth on this. And frankly, it took me a whole bunch of iterations to get it to simplify to this, because people present it in so many different overlapping ways. Okay. Practical real life is not this clean at all. And I want to walk you through an example of that. On the left, you see the machine learning problems we talked about on the right before. I just slid them over to the left. Practical real life, people will often not use one of these on its own. I want to walk you through two examples, totally realistic ones. Let's say I wanted to recommend some articles for you to read. And I had this whole set of articles I could choose from. Chances are, I am not just going to go do I'm not just going to do content recommendation. First, I might write a classifier to say, look, this piece of news, is it offensive or not offensive? I might take the result of that and then say, look, is this popular or not popular? Because popular is a real predictor of engagement, and I might want some mix between those. I then might do collaborative filtering to say, look, you and you tend to like articles that are the same, and you like these articles, so you might like them too, only on the output of the previous one. And finally, I might have a rule in place, because I don't want them all to be from one category of content, and so I might say, hey, I've got a rule, no more than 2 per. Totally realistic. Takes a bunch of experience to know to string these together. And so when you're working with machine learning scientists, working with one who has experience in your space can be really valuable. Can save you months and quarters worth of work pursuing paths that are less likely to lead to positive results. Another example. I want to predict some score. I don't know, maybe it's the housing price, maybe it's some other score. And I, the machine learning engineer, need to tune a whole bunch of parameters sitting in the background. They're often called hyperparameters. Now, I may have experience in the space to know what range these parameters should be in, but I may also just need to try a bunch. And so I may try 5 different versions of the model, right? Each with different hyperparameters in it. Now what do? Do I say, look, for each one of these, I've got a new training example. I could, one, say I'm going to pick the model that is most confident. So let's say a new training example comes up. Regression 2 says I am super confident that I've got the right answer. Great. So I'm going to use regression 2 for that example. I could do that over and over again. A whole other completely valid approach would be to say, you know what, I'm going to spread the wealth. I'm going to say 80% of the time I'm going to take regression 2, 20% of the time I'm going to take regression 3, 30% of the time I'm going to take regression 4. Ignore the fact that that's over 100. But you know, I could set that up in advance. This is what machine learning people deal with all the time, because it's not clear in advance which one they should have done. Which approach would have been better. Make sense? Questions? I'm going to walk through an example of a customer using this in real life to tie back to some of the strengths I shared about machine learning earlier. These will be in particular in the space that my company happens to work in, because that's where I've got examples from, but you could map these to those algorithms that we saw before. So Stella & Dot happens to be a business that empowers women to run their own business, selling jewelry and clothing in person, hosting events, and then straight up e-commerce on a website. They worked with us to work across all 3. This is some of the work they did in the e-commerce funnel. They started at the bottom of the funnel, and they tried a bunch of ideas. They tried, in fact, so many ideas on this page that when you multiplied them all out, there were more than 400 versions of this cart page running at once. Which one ended up having the most impact? To everyone's surprise, it was this. In this context, emotionally affirmative language at the moment of purchase, this looks great on you. Great choice. You've got great taste. Was the most impactful thing to do. We did complex, product recommendations down below, similar products. This had the biggest impact. No one could have predicted that. Machine did a nice job of finding that, drove 52% lift. Okay, they then went up funnel a little bit to the product detail page. Tried a bunch of ideas, had more than 300 versions of this page running. The idea that mattered the most, that had the biggest impact, having this purchase widget scroll down with their buyer while she scrolled through a whole bunch of images, used to scroll off the page. Okay, great, drove 8% lift. They then went all the way up funnel across their entire site. This is a view of their homepage. And they tried 25 different versions of the text in this bar, which is present on every page, and to everyone's surprise, it drove 400% lift in engagement on their site. For them, they would never have been able to do this in a practical amount of time with their lean marketing team. They had more than 700 versions of pages running for one part of one flow for one audience. For them, AI was a great lever. It helped them do a whole lot more. It's like having an army of analysts sitting in the background. I'm going to jump ahead because I see we're short on time, and we'll share to put the 3 buckets we talked about before in context. If you're going to do things manually, you can be data-driven and create a great experience for everyone. You have to keep an eye on your tests, and you've got to come up with new ones. If you want to then create great experiences for different segments of your audience, you can use rules. And some would say, hey, yes, that is AI. And most personalization vendors who are saying they do AI do this. Great, you can create a different experience for each part of your audience. And if you want, you can use machine learning to create the right experience for each unique visitor automatically. And I'd invite you to pick the right approach for you based on what we were talking about before. And so I would humbly suggest to you, AI can help you accelerate your career, get more done, help deliver more product engagement, more revenue for your company. And I invite you to use some of what we talked about here today to go do that at home. And now I'll open it up for questions.
What's your favorite or best book for learning the details of the AI? The problem I have is that most seem to be like how it's going to affect the economy, or it's like hardcore code. Someone who wants to learn the details like you have in your slide, but like maybe isn't a like stats PhD.
The question was, what's a good book for somebody who doesn't want to go deep into the stats but wants the intuition to learn about machine learning? I don't have a good answer, unfortunately. I will ask. For me, a lot of this, very transparently, came from my co-founders who learned a lot of very expensive lessons. And then, oh, I've got one for you. If you have the time, it'll take maybe similar amount of time to a book. Andrew Ng is a famous machine learning guy. He happened to have taught a course at Stanford. He founded a couple of companies on it. He worked at Baidu. Very nice guy, too. He taught a CS course at Stanford that he put the entire thing online. So if you've got a few hours, you can go to YouTube, get it for free. You can go to Coursera and see another version of it. Andrew Ng, NG is his last name, and look for his computer science course. I actually found the way he described it super helpful. He'll cover the math. He also will show you the intuition, and so you can get either or both. It will take a few hours, but I highly recommend it.
Thank you.
Yep. Question, and then I'll come to you.
So the 700 versions of the web page that you talked about earlier,
Yeah.
Stella and Dot example,
Yes.
do the AI algorithms help generate those pages or analyze the outcomes?
The question was, in the Stella and Dot example where there were 700 pages, did the AI create the ideas or did it analyze the results? In our case, for the problem we're trying to solve, the AI is analyzing the results and then deciding what to show. It's actually making the call about what am I going to show each individual visitor. Transparently, as a company, we thought maybe the AI should actually come up with the ideas. And when we talked to 100 potential customers, they said, that's great, it'll come up with them. And they were like, wait a minute, hold on. You're going to change my website with a machine? Okay, now I want control. I want approvals. I want all this additional stuff. And then we talked to them, and they said, I actually have a lot of ideas. I'm frustrated that I've never been able to try. So we did all of that part, the creativity and the empathy, human. The analyzing the results and deciding what to show, well-suited to machine. In our use case. Your use case may be different. Make sense? Cool. Welcome. Question.
You read 400 versions of a page. How on earth is their sample size big enough to actually gain meaningful insight?
Question was, if you read 400 versions of a page, how on earth was there enough sample size to gain insight, significance? So that happens to be part of how we're using machine learning. We are using it to learn more from every single impression with traditional, I'll just pick on our example. With traditional A/B testing or multivariate testing, you'd be taking your traffic and dividing it 400 ways. We're not doing that. We are intentionally showing winners more often, starving losers of traffic, and using AI to tease out the impact of each individual thing we're showing on a page. For example, if we had a customer that did 5 headlines, 5 images, 5 calls to action, you have 125 combinations. You may not have shown all 125, but you can learn something about all 125 when, like, headline 1, image 1, call to action 1 is shown, then headline 1, image 1, call to action 2 is shown. I can still learn about headline 1 and image 1 together regardless of what's shown in call to action. I see I'm not giving you a satisfactory answer. The AI does allow us to learn about things we're not showing because you can get partial matches and tease out the impact using machine learning. It's very specific to our particular approach. It's not that we violated the laws of stats. We didn't rewrite them. We just chose to solve a different problem using machine learning. If you want to talk more, I'm happy to afterwards. Other questions? Please.
This is about the continued performance of the model, and how do you assess that? How do you evaluate how the model is doing if it's degrading, and how do you correct for that?
Question is, how do you evaluate if a model is degrading over time, and how do you correct for that? I think experienced machine learning folks will tell you exactly to your point. You always need a holdback group. You always need a group that is seeing what was before. In my particular company, we happen to do that all the time. And when you are working in an environment where somebody's like, I put the algorithm in and now we're using it all the time, in my humble opinion, that should scare you some. You should have some holdback group so you can see comparison over time. And maybe that comparison is the last ML algorithm that you thought was great, and now you're testing the next one. But there should be some comparison so you can have an apples to apples contemporaneous view. Because if you're doing some before-after analysis, there's so many other things that may be coloring the results. Make sense? One last question. I think we're basically at time. Question?
Come across any third-party data repositories that you could quickly train a model? I see, like, the big companies have a monopoly on the deep learning in particular. How can we democratize AI?
I have wondered the same question a bunch. The question was, have you run into pools of data that you could use to train a model? So 2 parts of the answer. 1, I have found none. And we thought about that a lot early on in the company's life. 2, I came to appreciate what my co-founders already appreciated, which is you need data that's very bespoke to your problem. Right? We need data, in my company, we need data very specific to human interaction with websites, given some of the things they might see. And that's one set of data. Somebody trying to do the housing price thing, they need a totally different set of data, right? They need to scrape 1,000 MLS pages. And so I do think I share the frustration, and I think you're very right to be thinking about it, because I think too often, I know in my PM life and also in my marketing life, I'd be like, just go get this data. And then when you really dig into it, you realize somebody's going to go spend 3 months getting it, or $50,000 getting it, and there may be a different way to think about the problem to avoid needing that data at all. It's not a super satisfactory answer, but I think practically it's what we have today. Thanks for the questions. If you want to ping, I'm Yalif on Twitter or guy@intellimise.com, and I'll be around for questions after. Thanks for the time.